T-minus 10, 9, 8. We have a go for engine start. 6, 5, 4, 3, 2, 1. We have ignition. We have liftoff of Discovery on the second mission to Planet Earth research flight.
It leapfrogs ahead of the Shuttle Columbia and its mission for Germany, which was aborted 2 weeks ago just seconds before takeoff because of engine trouble. That mission is now set for later in April. Astronomers have discovered a comet that's broken into over a dozen pieces. Seen here in false color, the comet chunks cover an area as wide as the Earth.
It's stretched out into little pieces, which you can just about see here. And this is the first time anybody's ever seen a comet stretched out that way and broken into so many pieces. And what's also interesting about this particular comet is this faint trail that even extends farther than the train. And that's rarely seen in a comet.
Astronomers say the cometary debris is close to Jupiter and is not likely to come near Earth.
Seconds before liftoff. During the Discovery mission, a 5-person crew will be monitoring the Earth's ozone level in the upper and middle-level atmosphere. A shuttle mission last year confirmed a worrisome decline in the ozone layer, which protects the Earth's surface from harmful ultraviolet radiation.
Nighttime launch of the Space Shuttle Discovery. It is scheduled to lift off at 5:32 GMT Tuesday on its mission to study depletion of the Earth's ozone layer. This nighttime launch would put the shuttle on the best course for measuring ozone over North America. Chances of good weather listed at about 80%. And we'll have, of course, the launching live on CNN International if it takes place at that time.
The U.S. space program suffers another delay. The latest shuttle mission is aborted moments before liftoff. Once again, it was a case of all dressed up and nowhere to go for the NASA Space Shuttle astronauts. The scheduled early morning launch of the Shuttle Discovery was halted just 11 seconds before liftoff that is, and it was the second launch to be halted in the past 2 weeks. CNN's Tony Clark has more on this latest aborted mission.
Discovery's planned launch was already running an hour behind schedule because of high winds at the Kennedy Space Center. Then when the countdown did resume, it got down to T-minus 11 seconds and stopped.
And we have a cutoff. The countdown has stopped at the T-minus 11 second point.
Discovery's 3 main engines never ignited. Computers shut everything down early. Initial indications were that a valve failure led to Tuesday's scrub.
The valve gets command and closed by the onboard software inside of 31 seconds, and there's a position indicator measurement that would confirm that, and the software didn't pick up the position indicator measurement. However, other data, like the temperatures in the lines, indicated that the valve indeed did close.
It was a disappointed group of astronauts that climbed out of the shuttle and prepared to wait for another day to try again.
It's a noble attempt. We'll see you another day. Okay, sure appreciate it. I'm the last guy coming out, and the crew will be clear of the vehicle here in another couple of minutes. Thanks very much. We worked hard at it. We'll try it again. We're looking forward to it.
It was just 2 weeks ago that the Shuttle Columbia's launch was scrubbed in the final seconds because of a valve problem. That mission has been postponed until late this month.
We don't come in here to scrub launches. We come here to fly. Well, we've had a couple of relatively minor hardware problems, which is to be expected in a program of this complexity. We'll deal with those, and then we'll go fly.
NASA engineers will recheck the valves. Only then will they be sure of the exact cause of Tuesday morning's scrub and be able to begin planning to try to launch Discovery once again. Tony Clark, CNN, reporting.
The Space Shuttle Discovery was supposed to launch a half hour ago, but it is still on the pad. CNN's Tony Clark is here to tell us why. Tony?
Brian, right now the Shuttle Discovery is on hold at T-minus 9 minutes. In fact, here is a shot of Discovery as it is on the pad. There are 2 problems that NASA ground controllers are looking at. First is high winds, unusually high, at least past their limits of 12 knots at the landing site there at the Kennedy Space Center in case the shuttle had to return there. There is also a temperature sensor that is being looked at. Right now, everything is on hold while Those two problems are being examined. There is plenty of time, though, for a launch tonight. The launch window extends till 3:57 a.m. Eastern Time tonight, so ground controllers say they are confident that they should have a chance to launch Discovery tonight, and of course we will bring you that live. I'm Tony Clark at CNN Center. Brian?
Thank you very much, Tony. Tragic update. NASA is hoping for a launch of the space shuttle at 2:33 Eastern Time. You're looking at a live picture right there. They're getting ready about 15 minutes from now. Of course, CNN has live coverage. We will keep you updated as time goes on. Thanks a lot for watching. I'm Brian Christie at the CNN Center in Atlanta. And updating you on the launch of the space shuttle, NASA says the launch is scheduled to go into effect at 2:32 a.m. Eastern Time, less than 4 minutes from now. You're looking at a live picture. CNN's Tony Clark is on hand. We will have a live report coming up right here on CNN. And we'll be back right after this.
This is CNN International.
This is CNN Breaking News.
I'm Tony Clark at CNN Center. The shuttle Discovery is running about an hour late on its planned launch, originally set for 1:32 a.m. Eastern Time. Here we see a live shot of the main engines of the shuttle Discovery. It is currently set for a 2:32 Eastern Time launch. This is only the 8th time the shuttle will be launched at night. The shuttle launch because NASA ground controllers want to get the shuttle in the proper position to see sunrises in the northern hemisphere and sunsets in the southern hemisphere. The hour-long delay has been because of winds at the Kennedy Space Center. Now things seem to be going smoothly. Let's listen in on the last 2 minutes, last minute before launch.
T-minus 1 minute and counting. Discovery's launch marks the second shuttle flight this year and the 54th space shuttle launch for the program. T-minus 31 seconds.
Go for auto sequence start.
We have a go for auto sequence start. Discovery's computers now have control of critical vehicle functions for the remainder of the count.
15. Still breakout. Still have open is in progress. RSO hold indication is on. Some VFX for 101. LED is 1.
And we have a cutoff. The countdown has stopped at the T-minus 11 second point.
NTD CGLS ignition set 6 for safe. Engines 1, 2, 3 show code sequence 3. GLS is go for orbiter APU shutdown, and we show no MTS fire detector strips. PLT OTC perform APU shutdown.
Right now, the retractable arm is moving back so that the astronauts can get out of the shuttle. The engines did not ignite at 11 seconds before launch time. The units were shut down, the auxiliary power units shut down. Let's listen in.
CDR OTC, reconfigure heaters. CDR, roger.
Ground launch sequencer obviously picked up something that was not quite right to launch the shuttle Discovery and stopped the countdown at the T-minus 11 second mark.
CLS NTD, can you give me primary safety complete? I'll put on. I'll go for transition to G9. Flight NTD, can you give me VSS FCC buffer clear, ready for G9?
It's complete and we're ready for G9.
CMPL, C-Lock, CLHY, NTD, verify configure for G1 to G9 off transition, CMPL. CMPL verified. C-Lock. TD, this is C-Lock, hold transition.
The team is now busy safing the systems on board the orbiter and re-extending the orbiter access arm. No word yet at this point exactly what caused the countdown to stop.
Shutdown's complete, OTC. Copy, PLC. This APU. APU, perform APU heater activation for sequence 42. Copy. CDR OTC. Go ahead. Panel F7.
This is the second time in a couple of weeks. The last two now launch attempts have failed in the final seconds. This one at 11 seconds before launch time. Right now, NASA ground controllers are trying to find out what went wrong, and they are also going through the procedures to, as they describe it, safe the shuttle, turn off all the power that could ignite. The shuttle is loaded with fuel at this point. It becomes a potentially dangerous situation, so that's why they hurriedly go through and shut off everything to eliminate any danger. At this point, as I say, there is no firm indication as to what caused the shutdown at 11 seconds, T-minus 11 seconds. And of course, we will be following that throughout the morning and bring you up to date with the latest throughout the morning. I'm Tony Clark at CNN Center. CNN.
This has been a special report from CNN International.
Dating now, Space Shuttle Discovery remains on the launch pad at Cape Canaveral, Florida. The launch was first delayed because of high crosswinds at an emergency landing runway. The countdown was then stopped at 11 seconds by the NASA computers, which automatically take over the count. NASA is now in the process of getting the astronauts off the shuttle. No word on whether or not NASA will make another launch attempt before the window expires in about 2 hours. Probably not.
Zum zweiten Mal nacheinander ist der Start einer Raumfähre in Cape Canaveral gescheitert. 11 Sekunden vor dem Abheben wurde der Countdown für die Discovery abgebrochen. NASA-Ingenieure vermuten, dass ein fehlerhaftes Ventil daran schuld war. 5 Astronauten an Bord, darunter eine Frau, sollten die dünner werdende Ozonschicht der Erde untersuchen. Nächster Startversuch ist möglicherweise am kommenden Donnerstag. Erst am 22. März war die zweite deutsche Raumfahrtmission mit der Columbia nur 3 Sekunden vor dem Start abgebrochen worden.
Auch einen Programmfehler für möglich. Menschliches Versagen? Die Raumfahrtbehörde verharmlost die Pannenserie. Wir wollen hier keine Starts abbrechen, wir wollen fliegen und das werden wir auch tun. Wir hatten einige kleine Probleme, das ist normal bei solch einem komplizierten Programm. Wir lösen diese Probleme und dann fliegen wir wieder. Auch die deutsche D2-Mission scheiterte vor 14 Tagen an einem kleinen Fehler. 3 Sekunden vor dem Abheben, eine Panne mit Kosten in Millionenhöhe. Der gesamte NASA-Flugplan bis zum Jahresende ist jetzt in Gefahr. Frühestens Donnerstag rechnen NASA-Experten mit einem erneuten Startversuch. Wenn dann alles klappt, soll die Discovery-Mission die Ozonschicht untersuchen.
Pech für die NASA. 11 Sekunden vor dem Start brach ein Computer den Countdown für die Raumfähre Discovery ab. Ein defektes Instrument war schuld. Erst vor 2 Wochen war der Start der Columbia mit 2 deutschen Astronauten gescheitert.
Discovery in Cape Canaveral in Florida ist heute auf unbestimmte Zeit verschoben worden. Das teilte die Raumfahrtbehörde NASA mit. Zuvor war der Start 11 Sekunden vor Ablauf des Countdowns gestoppt worden.
Der Computer brach den Start ab, noch bevor die Triebwerke der Discovery gezündet hatten. Es war der zweite Fehlstart einer US-Raumfähre innerhalb von 2 Wochen. Experten zufolge könnte das Versagen eines Ventils für den missglückten Startversuch verantwortlich sein. Enttäuscht mussten die 5 Astronauten, darunter eine Frau, die Raumfähre verlassen. Die geplanten Experimente sollten Aufschlüsse über die Sonne und die Ozonschicht der Erde liefern. Deutschland, Frankreich und Belgien stellten 3 der 7 wissenschaftlichen Instrumente für die Mission ATLAS-2.
Zum zweiten Mal hintereinander ist in Cape Canaveral eine Weltraummission gescheitert. 11 Sekunden vor dem Start der Raumfähre Discovery wurde der Countdown abgebrochen. Die Ursache: ein Ventil im Antriebssystem funktionierte nicht. Die 5 Astronauten an Bord der Discovery sollten die dünner werdende Ozonschicht untersuchen. Bereits vor 14 Tagen war die deutsch-amerikanische Mission D2 3 Sekunden vor dem Start abgebrochen worden.
Die NASA hat offenbar kein Glück mehr mit ihren Shuttle-Starts.
Nachdem bereits vor 2 Wochen der Countdown für die Columbia abgebrochen werden musste, scheiterte jetzt auch der Versuch, die Raumfähre Discovery ins All zu schießen. 11 Sekunden vor dem geplanten Start schaltete ein Computer den Countdown automatisch ab. Woran es dieses Mal lag, ist noch nicht klar. Die 5 Astronauten an Bord der Raumfähre sollten auf ihrem 8-tägigen Flug die Ozonschicht über der Erde untersuchen.
The countdown has stopped at the T-minus 11-second point.
Just 11 seconds before liftoff, NASA computers halted the launch of the Space Shuttle Discovery. This marks the second aborted shuttle mission in 2 weeks. Computers on board Discovery indicated that a valve didn't close automatically, but NASA engineers think the valve was closed and that a bad circuit might be at fault. NASA has tentatively scheduled a second launch attempt for Thursday. Discovery's mission is to study the Earth's thinning ozone layer.
A shuttle off the ground. The countdown has been resumed for the planned launch of Discovery on a mission to study the Earth's ozone layer. Engineers believe that a faulty computer circuit caused Tuesday's last-second shutdown. And if it all goes well, Discovery is to lift off Thursday at 5:29 GMT. CNN International is planning live coverage.
This time, Discovery will lift off as planned. The space shuttle, with a crew of 5 astronauts, is now ready and waiting on the launch pad at the Kennedy Space Center in Florida. On its first attempt Tuesday, computers automatically halted Discovery's countdown 11 seconds before liftoff. The planned 8-day flight will be the first shuttle mission since January and the 16th for Discovery. The astronauts will carry out experiments in atmospheric research, the focus of which will be the ozone layer. CNN International plans to carry the launch of Discovery live in just under 1/2 hour.
Zu schicken. Der Countdown am Dienstagmorgen war mehrfach angehalten und schließlich kurz vor Zündung der Triebwerke abgebrochen worden. Ingenieure der Raumfahrtbehörde NASA vermuten, dass ein Ventilfehler in einem der Triebwerke die computergesteuerte Abschaltung ausgelöst hatte. Die Astronauten, 4 Männer und eine Frau, haben vor, die Erdatmosphäre zu untersuchen, vor allem die Ausdehnung und Konzentration der Ozonschicht. Der 54. Shuttle-Flug soll 8 Tage dauern.
Launch of Discovery scheduled to take place in just a few minutes. CNN International will be there live.
Final purge of engines is underway, and the engine
With the Space Shuttle Discovery is due to be launched momentarily. This is the second attempt to carry out this mission. Just 48 hours ago, the countdown for Discovery's launch was halted 11 seconds before liftoff. 5 astronauts are aboard. 1 woman, the first Hispanic one, and they are prepared to spend 8 days in space conducting atmospheric experiments. And the countdown is in its final minute. Let's watch.
15.
T-minus 10, 9, 8. We have a go for engine start. 6, 5, 4, 3, 2, 1. We have ignition. We have liftoff of Discovery on the second mission to Planet Earth research flight.
Roll program, Houston.
Roger, roll, Discovery.
Houston now controlling. Discovery's underway, and it's rolled on course for a 57-degree orbit. Three engines on board Discovery now throttling back to 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic. Discovery now traveling 1,000 miles an hour, 3 miles east of the launch pad, altitude 6 miles.
Discovery, go at throttle up.
Roger, go at throttle up.
3 engines on Discovery now back at full throttle. Good hydraulics, good electrical systems. 1.5 minutes since launch, Discovery's already burned more than 2.5 million pounds of propellant and weighs less than half of what it did at liftoff. Altitude now 15
And apparently a
miles.
picture-perfect start for the Discovery Shuttle. And in 8 days they will come back to Earth, and of course we will bring you the landing live.
Und es wird jetzt gleich aufhören. Und das ist sozusagen der kritische Punkt für die NASA-Techniker. Wenn es bis dahin klappt, dann sind die also ganz froh. Wie gesagt, die Geschwindigkeit des Shuttles jetzt in diesem Moment, wo der Abtrennvorgang beginnt, bereits 5-fache Schallgeschwindigkeit. Und die Beschleunigung drückt die Astronauten nun mit dem Dreifachen ihres Gewichts in die Sitze.
Bedeutet
die applaudiert alles.
Bedeutet
Sie
das,
hören
wenn dieser...
vielleicht,
Ja, Ranga, bedeutet das, wenn dieser Punkt jetzt überwunden ist, dass man sagen kann, das Ganze ist sicher gestartet, es kann jetzt nicht mehr so viel passieren?
genau, also in dem Moment, wo die Feststoffraketen abgekoppelt haben, ist es so, dass der Shuttle wieder steuerbar ist. Diese Feststoffraketen, die kann man zünden, aber in dem Moment brennen sie, man kann sie nicht wieder abstellen. Und Sie haben auch hier am Applaus gehört, dass immer noch Challenger irgendwo im Nacken ist. Und man ist immer froh, wenn man diese erste Phase hier überwunden hat.
Ranga, es hat geklappt. Feiern Sie schön mit den Kollegen. Vielen Dank erstmal für den Bericht.
Dienstagmorgen mehrfach angehalten und schließlich kurz vor Zündung der Triebwerke wegen eines technischen Defekts abgebrochen worden war. Die Astronauten, 4 Männer und eine Frau, haben die Aufgabe, die Erdatmosphäre zu untersuchen, vor allem die Ausdehnung und Konzentration der Ozonschicht. Der 54. Shuttle-Flug soll 8 Tage dauern.
Of relief at the Kennedy Space Center in this, the second attempt to launch Discovery. This one, unlike the attempt 2 days ago, went very well.
We have ignition. We have liftoff of Discovery on the second mission to Planet Earth research flight.
At this moment, Discovery is about 155 nautical miles up and going over the Persian Gulf area on this planned 8-day mission. This is only the 8th time out of 54 launches that the shuttle's been launched at night. The reason for the night launch, that equipment in the shuttle's payload bay. It's equipment to measure the stratosphere, gases in the stratosphere. It is pointed towards the sun during daylight hours, and then the shuttle is maneuvered towards deep space during the darkness hours to allow the instruments to cool. Those instruments will get a reading on the ozone layer. Recent studies have indicated that there has been a thinning of the ozone layer over the northern hemisphere. In the past, it's been known about the hole in the ozone over the Antarctic. And now, during this mission, which is called the second mission to planet Earth, the astronauts and the equipment on board will be used to see about the thickness of the ozone layer over the northern hemisphere. There are 5 astronauts on board. They will work in 2 teams to keep the shuttle working round the clock. It will be, as I say, an 8-day, possibly a 9-day mission, and the astronauts say that they think this will go a long way to increasing science's knowledge about the atmosphere and the dangers of the thinning ozone layer. I'm Tony Clark at CNN Center.
10, 9, 8. We have a go for engine start. 6, 5, 4, 3, 2, 1. We have ignition. We have liftoff.
A NASA launch official said it best. If at first you don't succeed, wait a couple of days and try again. The U.S. Space Agency blasted the Shuttle Discovery into orbit early Thursday, 2 days after a computer glitch halted the countdown just 11 seconds before launch. Once in space, the Discovery astronauts got right to work. They turned on instruments in the payload bay that will help Discovery measure the Earth's ozone layer. The cost-conscious U.S. government has asked NASA to design a less expensive version of its planned space station Freedom. And to do that, it's asking NASA to seek help from Russia. CNN's John Holloman explains why.
The Russian space station Mir could become the backbone of the West's effort to put a space station into orbit. NASA is struggling to build a station that's cheaper and smaller and available sooner than the $30 billion Freedom design. The U.S. Space Agency has been ordered by the White House to work closely with the Russians in the redesign effort.
We hope to maybe get some more help from some Russian advisors in the near future, where we may be asking some of them to come over here and consult with us and tell us what they've got and what their capabilities are.
NASA is already looking at the Russian Soyuz spacecraft as a lifeboat for the American station. And just this week, NASA officials started considering the huge Russian Energia rocket to launch major segments of the station. The Russian rocket can carry 4 times as much as the space shuttle into orbit at 1/2 the cost. Outside analysts say the Clinton plan for a cut-rate space station will be impossible without Russian help.
Building a space station with the Russians is the only way that the Clinton administration is going to achieve its budget reductions and achieve the goals of its space effort.
And Pike says the advantages of U.S.-Russian cooperation go far beyond space exploration.
Stabilizing democracy in Russia, precluding missile proliferation, and helping out the American aerospace industry, that it really does solve so many problems, both domestic and foreign, that it's the only way to go.
NASA managers have always opposed the idea of combining a Russian space station with their own. But tight budgets, combined with the prospect of getting a station into orbit within 5 years, with 9 astronauts and cosmonauts aboard, is causing some of them to change their minds. John Holloman, CNN at NASA headquarters in Washington.
Um 7:29 Uhr mitteleuropäischer Zeit brach die 54. Shuttle-Mission auf. Am Dienstag war der Start wegen eines defekten Messgerätes abgebrochen worden.
Aufatmen bei der NASA. Planmäßig um 1:29 Uhr Ortszeit hob die Raumfähre Discovery vom US-Raumfahrtzentrum Cape Canaveral ab, zum 54. Flug einer US-Raumfähre. Am vergangenen Dienstag war der Start der Fähre gleich zweimal schiefgegangen. Einmal musste der Countdown wegen stürmischer Winde abgebrochen werden. Das zweite Mal sorgte der Computer kurz vor dem Countdown für das Aus. Bei der bisher geglückten Mission werden 5 Astronauten, darunter eine Frau, die Ozonschicht der Erde untersuchen und die Sonnenstrahlung messen. Planet Erde ist der Name des Programms, für das die Crew der Discovery diesmal im Einsatz ist. Planet Erde erforscht die Umweltbedingungen unseres Planeten. Die gesammelten Informationen sollen als Grundlage für die Umweltschutzpolitik dienen.
Dienstag war der erste Countdown wegen eines Computerfehlers abgebrochen worden. Die Astronauten, 4 Männer und eine Frau, sollen die Erdatmosphäre untersuchen, vor allem das Ozonloch über der nördlichen Erdhalbkugel. Der Flug wird voraussichtlich 8 Tage dauern.
Atmen bei der NASA. Die amerikanische Raumfähre Discovery ist heute Morgen vom Weltraumbahnhof in Cape Canaveral gestartet. Vorgestern musste der erste Versuch 11 Sekunden vor dem Start abgebrochen werden. Ursache war ein Computerfehler.
Heute Morgen kurz vor dem Start. Die 5 Astronauten auf dem Weg in das Shuttle. Zum ersten Mal fliegt auch eine Frau aus Lateinamerika mit ins All. Noch einmal Spannung beim Countdown. Dann zünden pünktlich um 7:29 Uhr mitteleuropäischer Zeit die riesigen Startraketen. In Florida ist noch dunkle Nacht, als die Discovery in die Umlaufbahn abhebt. 8 Tage lang wird die Shuttle-Besatzung die immer dünner werdende Ozonschicht der Erde erforschen. An dem sogenannten Projekt Planet Erde arbeitet die NASA zusammen mit europäischen Wissenschaftlern, unter anderem aus Deutschland.
5 Astronauten der US-Raumfähre Discovery im All. Sie sollen unter anderem die Zerstörung der Ozonschicht erforschen.
Von Cape Canaveral startete in der vergangenen Nacht Discovery. Der amerikanische Raumgleiter hob 2 Tage später ab als geplant. Zu der Verzögerung hatte ein Computerfehler beigetragen. Der Start aus flugtechnischen Gründen in die Nachtstunden verlegt, war entlang der Atlantikküste weithin zu sehen. Einem Instrument am Ende der geöffneten Discovery-Ladebucht gilt die meiste Aufmerksamkeit in den kommenden 8 Tagen. Das Instrument ähnelt einer Satellitenschüssel. Es kann sich nach vorn neigen und zurück. Schon früher war es an Bord. Strahlen gehen von ihm aus und werden wieder aufgefangen. Je weniger, desto durchlöcherter, desto schlechter die Ozonschicht unterhalb von Discovery. Damit Wissenschaftler am Boden verwertbare Messergebnisse erhalten, muss Discovery bei seinen Erdumrundungen in Seitenlage fliegen.
Discovery gelanceerd. Na de mislukte poging van dinsdag vertrokken de 5 bemanningsleden vanmorgen in alle donkere vroegte van Cape Canaveral, Florida. Ze zullen 8 dagen in de ruimte blijven om onder meer de atmosfeer van de aarde te bestuderen en de schade aan de ozonlaag. De oranje gloed van de Discovery was tot in New York te zien. Een lancering van ruimteveren 's nachts is een grote uitzondering.
Slow down some of the ozone research now underway. 2 monitors are not working properly, making it difficult for astronauts to send data back to Earth. NASA may be forced to use a backup recorder to store the material until Discovery returns to the ground April 16th.
Having some trouble sending ozone measurements back to the Earth. The difficulty apparently stems from faulty monitors. Astronauts and ground controllers are working to resolve the problem, and mission scientists say the crew will get all the necessary data. Discovery's major goal is to study increasing loss of ozone over the northern hemisphere. On Thursday, astronauts had some technical difficulties with some of the instruments on board. Not long after turning on the equipment meant to measure the Earth's ozone layer, the astronauts were unable to send vital data back to ground control. But NASA says a backup recorder on the shuttle will continue to hold all that needed data.
The technical problems facing the crew and their experiments. NASA is recording the data on the sun and the Earth's ozone layer on tape rather than sending it back to Earth. Sunday, the astronauts will deploy a satellite to study the solar winds.
Discovery ozone monitors. It's keeping scientists on the ground from looking at the Earth's atmosphere firsthand. Sean Caleb's reports.
This is the culprit, Discovery's antenna. It's supposed to be relaying vital information about the growing environmental concern of the Earth's ozone layer. But the antenna isn't working properly.
It's going to take some time, but we're looking at it, and we think that we might be able to get it taken care of, but we're going to have to keep looking at it.
In the meantime, the shuttle crew will be able to store more than half the critical information on a backup tape recorder aboard Discovery. The 8-day mission is focusing on the diminishing ozone layer over the northern hemisphere. A series of instruments called ATLAS, mounted in the cargo bay, will check effects of pollutants on the ozone layer. NASA scientists say environmental problems like the ozone layer are incredibly complex, and it takes millions of dollars in research to even begin to reverse the damage in the upper stratosphere. But information alone won't solve the problem. Scientists say it also takes action.
The best hope really for stopping ozone depletion is to reduce the amount of chlorofluorocarbons in the atmosphere, and the only real way that we know how to do that is to cut them off at the source. That means not to emit them into the atmosphere in the first place.
Scientists say depletion of the ozone layer is a global problem. The protective layer shields people from the sun's harmful ultraviolet rays that can lead to cases of skin cancer, cataracts, and other damage to animal and plant life. Many scientists are cheering ATLAS research, but say what we learn in space is just the tip of the iceberg.
It's going to affect our health. It could affect terrestrial plant growth. We don't know. If we're going to mitigate effects on terrestrial plant growth, we ought to have a study to say which plants grow best in conditions of high UV radiation.
Industry, environmentalists, and scientists may have differing views on the problem with the ozone layer, but they agree information gathered from this shuttle mission could offer the best chance they have yet of solving the global dilemma. Sean Caleb, CNN, reporting.
Discovery bleibt vom Pech verfolgt. Nach dem verschobenen Start am Donnerstag hat es nun auch am zweiten Tag im All Probleme gegeben. Die 5 Astronauten, eine Frau und 4 Männer, kämpfen mit Übertragungsschwierigkeiten. 2 Messsonden an Bord senden unzureichende Informationen zur Erde. Zu befürchten ist, dass die erhofften Daten geringer als erwartet ausfallen werden. Auf der Ladebucht der Discovery befindet sich eine Forschungsplattform, auf der 6 Experimente durchgeführt werden sollen, unter anderem Untersuchungen über die Ozonschicht. Am kommenden Freitag wird der Shuttle zur Erde zurückkehren.
Relay antenna for the problem. The crew is running out of computer space to store the information it's gathering. Scientists hope to use the data to better understand the ozone layer. The shuttle is scheduled to land next Friday.
Nachdem der Start vor 2 Tagen endlich geglückt war, haben die Astronauten nun im All mit Schwierigkeiten zu kämpfen. Die Messsonden der Weltraumfähre funktionieren nicht richtig. Daten über die Ozonschicht können dadurch nicht direkt an die Bodenstation gegeben werden. Allerdings kann eine der Sonden alle von ihr gemessenen Daten bis zur Landung am 16. April speichern. Die 8-tägige Forschungsreise soll den Wissenschaftlern neue Erkenntnisse über die immer dünner werdende Ozonschicht liefern.
Discovery are back at work after a computer glitch temporarily interrupted an experiment today. The failure affected instruments collecting solar and atmospheric data. NASA says the loss was not very significant. The main purpose of the shuttle's 8-day mission is to collect data on the Earth's diminishing ozone layer. One astronaut says she's having a lot of fun looking out the spacecraft's windows, seeing the spectacular views.
Gelöst. Wenn nicht innerhalb von 2 Tagen eine defekte Antenne repariert ist, sind wichtige Informationen über das Ozonloch verloren.
In 300 Kilometern Höhe kreist die Discovery um die Erde. Die Sonden in der offenen Ladebucht messen die Gase in der Atmosphäre. Die Ergebnisse sollen Aufschluss darüber geben, wie die Ozonschicht geschädigt ist. Am dritten Tag ihrer Mission haben die Astronauten, 4 Männer und eine Frau, mit einer Spezialkamera Aufnahmen von der Erde gemacht. Sogar Ölverschmutzungen der Meere sind vom All aus zu machen. Morgen soll ein Messsatellit ausgesetzt werden. Der 54. Shuttleflug dauert noch bis kommenden Freitag.
The Earth's thinning ozone layer, they did have a slight setback today. A computer crashed, but it was fixed quickly, and NASA says little information was lost. NASA says the glitch is offset by a breakthrough of sorts that will allow more information to be gathered.
We've had a tremendous amount of success in opening up our options, and the good news I have for you today is we are no longer limited to the number of data passes for ATMOS that the ATMOS dedicated recorder can support. We now have ways of recording data on board and dumping it to the ground such that we can continue to take ATMOS passes even after the ATMOS recorder is all filled up.
A highlight of the mission, releasing a solar science spacecraft, is set for tomorrow morning.
Shuttle Discovery deployed a free-flying satellite known as Spartan. The shuttle's triple-jointed robot arm lifted Spartan from its cargo bay and set it free. The crew will use it to study solar winds and the sun's atmosphere, which scientists say can affect the Earth's weather patterns. Spartan will float solo until it's retrieved on Tuesday and brought back into the shuttle.
Das Mittelmeer angeschaut, erklärt der Astronaut den Schülern. Wir können erkennen, an welchen Stellen Schiffe Schmutzwasser oder Dieseltreibstoff abgelassen haben. Doch es ist schwer für uns, den Grad der Verschmutzung zu erkennen. Zur Erforschung der Ozonschicht hat die Crew der Discovery einen Satelliten ausgesetzt. Er soll Daten über die Größe des Ozonlochs sammeln. Seit 18 Jahren ist es heute Nacht zum ersten Mal wieder gelungen, Kontakt zu einem russischen Raumschiff aufzunehmen. Die US-Fähre konnte ein kurzes Gespräch mit der russischen Raumstation Mir führen.
Nehmen die Sonne unter die Lupe. Sie befinden sich seit Donnerstag an Bord der Discovery und wollen herausfinden, ob es zwischen der Sonnenenergie und dem Ozonloch einen Zusammenhang gibt. Dabei geht es auch um die Frage, ob Veränderungen in der Erdatmosphäre durch die Sonne oder durch menschliche Aktivitäten verursacht werden. In der vergangenen Nacht ist es den Astronauten seit 18 Jahren zum ersten Mal gelungen, mit der russischen Raumstation Mir Kontakt aufzunehmen. Am 16. April soll die Discovery wieder zur Erde zurückkehren.
Konnten Schüler aus der Nähe von London den Astronauten der Discovery Fragen stellen. Das Shuttle kreiste zu dem Zeitpunkt gerade über der nördlichen Erdhalbkugel, um die Umweltverschmutzung zu erforschen. Wir haben uns besonders das Mittelmeer angeschaut, erklärt der Astronaut den Schülern. Wir können erkennen, an welchen Stellen Schiffe Schmutzwasser oder Dieseltreibstoff abgelassen haben. Doch es ist schwer für uns, den Grad der Verschmutzung zu erkennen.
Experimente gemacht. Sie setzten einen Satelliten aus, der die Sonnenstrahlung untersuchen soll.
Um 8:11 Uhr klinkte der Roboterarm der Discovery den Satelliten Spartan aus. 2 Teleskope sollen die Corona, die äußerste Hülle der Sonne, beobachten und die Partikelwinde messen, die von der Sonne ausgehen. Denn diese geladenen Teilchen führen oft zu Störungen bei Kommunikationssystemen. Der 1,3 Tonnen schwere und $6 Millionen teure Satellit soll am Dienstag wieder an Bord geholt werden.
Einen Satelliten aus, mit dem die Sonne untersucht werden soll. Die Astronauten erforschen den chemischen Zusammenhang zwischen Sonnenenergie und der Ozonschicht der Erde.
Die US-Raumfähre Discovery haben heute einen Satelliten im All ausgesetzt. Er soll Daten über die Solarwinde und die Atmosphäre der Sonne sammeln. Die Discovery war am Donnerstag zu einem 8-tägigen Flug gestartet.
Discovery flog in den Weltraum, um die Erde zu erkunden. Die meisten Experimente in der Ladebucht des Shuttle dienen der Erforschung der Erdatmosphäre. Längst weiß man, dass sich ihre Zusammensetzung verändert, vielleicht in gefährlicher Weise. Ellen Ochoa, die zuständige Wissenschaftlerin an Bord, erklärt, wie man von oben die Präsenz von 40 verschiedenen Chemikalien messen kann. Nicht alles klappte gleich auf Anhieb. Sorge machte vor allem die Datenverbindung zur Bodenstation. Die Crew in ihrem milliardenteuren Raumschiff erlebte den Frust, den auch irdische Computeramateure kennen, als die Speicher der Bordcomputer überflossen. Da Menschen an Bord sind, ließ sich das inzwischen reparieren. Heute Morgen wurde der Sonnenbeobachtungssatellit Spartan ausgesetzt, damit er fern von Discovery ungestört arbeiten kann. Vor der Rückkehr zur Erde soll er wieder eingesammelt werden. Nebenbei gelang eine Funkverbindung mit den russischen Kollegen von der Raumstation Mir. Die Zeit reichte nur für kurze Grüße, aber der Kontakt ist vielleicht Vorläufer für enge Zusammenarbeit in der Zukunft. Experimente wie das von Michael Foale zur Messung des Ozonlochs über der Nordhalbkugel der Erde, auch über Norddeutschland, gehen schließlich die ganze Menschheit an. Sie funktionieren reibungslos. Die Daten werden in einigen Monaten allen zur Verfügung stehen. Die größten Gefahren für die NASA liegen derzeit nicht im Weltraum, sondern auf diesem Hügel in Washington. Der Kongress hat die Mittel für das nächste große Projekt, die Raumstation Freiheit, so stark zusammengestrichen, dass ihre Existenz gefährdet ist. Die Antwort der NASA liegt in mehr Missionen zum Planeten Erde, wie sie das nennen, und in verstärkter Zusammenarbeit mit den Japanern, Europa und nun auch den Russen.
Einen Forschungssatelliten ausgesetzt. Der 6 Millionen Dollar teure und 4,5 Kilogramm schwere Satellit mit Namen Spartan wurde von einem Greifarm aus der Ladeluke des Shuttles gehoben und auf seine Bahn gebracht. Er soll die Atmosphäre der Sonne und die sogenannten Solarwinde erforschen. Die Wissenschaftler wollen zum Beispiel wissen, warum der Strahlenkranz der Sonne heißer ist als ihre Oberfläche. Am Dienstag soll der kleine Forschungssatellit wieder eingeholt werden. Am 4. Tag ihrer Mission erfolgreich einen Forschungssatelliten ausgesetzt. Der 6 Millionen Dollar teure und 4,5 Kilogramm schwere Satellit mit Namen Spartan wurde von einem Greifarm aus der Ladeluke des Shuttles gehoben und auf seine Bahn gebracht. Er soll die Atmosphäre der Sonne und die sogenannten Solarwinde erforschen. Die Wissenschaftler wollen zum Beispiel wissen, warum der Strahlenkranz der Sonne heißer ist als ihre Oberfläche. Am Dienstag soll der kleine Forschungssatellit wieder eingeholt werden.
60 Kilometer über uns rast die US-Raumfähre Discovery mit einer Geschwindigkeit von 28.000 Kilometern pro Stunde um die Erde. Über Nordrhein-Westfalen soll die Raumfähre nach Auskunft der NASA am kommenden Donnerstag zu sehen sein. Bei klarer Sicht müssen Sie allerdings Punkt 4:31 Uhr aus dem Fenster schauen. 1 Minute später ist die Discovery schon wieder verschwunden.
Chemieunterricht im Weltall. Ein Astronaut erklärt ein Molekül. Aber die Astronauten der US-Raumfähre Discovery haben nicht nur Modelle von Molekülen, sondern auch einen Meteorologen besonderer Art an Bord. Sein Name Spartan. Gewicht nicht mal 3 Kilogramm. Kosten satte 10 Millionen Mark. Mit Hilfe eines Robotarms wurde Spartan gerade hier ins All gesetzt. Er soll Daten über die Sonnenkorona sowie Partikelwinde sammeln, die von der Sonne ausgehen. Der Mini-Meteorologe ist mit 2 Teleskopen ausgestattet und wird bis zum kommenden Dienstag im Weltraum kreisen. Die Astronauten können von ihrer Position im All auch die Umweltverschmutzung unseres Planeten erkennen. Kommandant Ken Cameron sagte in einem Funkgespräch mit Schülern aus der englischen Grafschaft Cumbria: Wir haben uns besonders das Mittelmeer angeschaut. Wir können sehen, an welchen Stellen die Schiffe Schmutzwasser oder Dieseltreibstoff abgelassen haben. Aber es ist schwer, rein optisch den Grad der Verschmutzung zu bestimmen.
Aus dem Weltraum zurück auf die Erde, aber lassen Sie uns beim Thema bleiben. In Rostock, sonst eher bekannt für Schiffbau- und Fischereiindustrien, arbeitet eine Firma an einem unbemannten Raumgleiter. Plato heißt das Projekt und fliegen soll es, wenn alles klappt, frühestens 1997.
Rostock-Warnemünde. In der Saison bevölkern Touristen diese Ecke der Hansestadt. Den Rest des Jahres liegt das Badeparadies fast verlassen. Industrie gibt es hier kaum. Die ansässige Warnow-Werft speckte kräftig ab. Damit setzte auch eine Auftragsflaute im ehemaligen Institut für Schiffbautechnik ein. Doch hier ging man neue Wege.
Dadurch, dass das Institut für Schiffbautechnik auch schon in seiner Vergangenheit komplexe Systeme entwickelt hat und als Systemführer gearbeitet hat, ist bei der Erno Raumfahrttechnik GmbH das Interesse an dieser Firma geweckt worden. Und mit dem Erwerb des Instituts für Schiffbautechnik und Umweltschutz durch Erno Raumfahrttechnik sind wir mit den neuen Aufgabenfeldern der Raumfahrttechnik konfrontiert worden und arbeiten jetzt seit 1991 an verschiedenen Raumfahrtprojekten mit.
Mit dem Projekt Plato kam die umprofilierte Raumfahrt- und Systemtechnik GmbH an die Schlagzeilen. Seit 1991 entwickelt die Warnemünder Firma das Modell eines unbemannten Raumgleiters.
Plato wird mit der europäischen Rakete Ariane 44L gestartet, bringt eine wissenschaftliche Forschungsplattform in den erdnahen Orbit und soll selbsttätig und antriebslos in die Erdatmosphäre wieder eintreten und auf einem Landeplatz in Südeuropa landen.
Im Gegensatz zu herkömmlichen Shuttles soll Plato Forschungsplattformen ins Orbit transportieren und nach bis zu einjährigem Aufenthalt im All zur Erde zurückkehren. Erste freifliegende Windkanalversuche mit dem 1,20 Meter langen Modell des Gleiters wurden in Dresden bereits durchgeführt. Im Unterschallbereich bewies Plato seine Tauglichkeit. Versuche oberhalb der Schallgrenze stehen noch aus. Eine Kooperation mit einem Raumfahrtzentrum in der GUS war geplant. Dort existieren die technischen Voraussetzungen, um die Testreihe abzuschließen. Diese Zusammenarbeit wurde vorläufig aus Kostengründen auf Eis gelegt. Die Bundesrepublik muss sparen auf dem Gebiet der Raumfahrttechnik. Projekte wie das Expressprogramm gehen vor, Plato gleitet in die Warteschleife. Die Warnemünder Raumfahrttechniker fassen eine Zusammenarbeit mit ausländischen Firmen ins Auge, die Kosten würden gesenkt. Doch selbst wenn diese nicht zustande kommt, sollen die restlichen Versuche im nächsten Jahr ihren Abschluss finden. Im günstigsten Fall geht der in Rostock projektierte Raumgleiter dann 1997 in die Luft.
Satellite, it carries 2 telescopes and scientific instruments to analyze the sun's corona. The crew will allow the retrievable satellite to orbit freely through tomorrow before pulling it back into the shuttle. They hope it'll shed light on how the sun's halo generates solar winds, which can blast by Earth at nearly 1 million miles per hour and disrupt communications systems.
Haben den Forschungssatelliten Spartan wieder an Bord genommen. Sie benutzten dazu einen Greifarm. Der 6 Millionen Dollar teure Satellit war am Sonntag ausgesetzt worden. Mit seiner Hilfe wurde untersucht, wie die Sonnenwinde entstehen und ob die Sonne für Veränderungen der Erdatmosphäre mitverantwortlich ist. Von der Discovery-Mission erhoffen sich die Wissenschaftler Informationen über die Zerstörung der Ozonschicht.
Spartan ist vom Discovery-Team erfolgreich abgeschlossen worden. Mit einem Greifarm holte die Besatzung den Satelliten bei der Fluggeschwindigkeit von 28.000 Stundenkilometern ein. Der 6 Millionen Dollar teure Forschungssatellit lagert jetzt wieder in der Ladebucht der Raumfähre. Spartan soll den Wissenschaftlern eine Flut von Daten aus der Sonnenatmosphäre liefern. Unter anderem geht es dabei um das Phänomen der Sonnenwinde. Die Raumfähre selbst sammelt zugleich laufend weitere Messdaten über die Ozonschicht der Erde. Und außerdem testen die Astronauten auch eine neuartige Spionagekamera.
First, the Space Shuttle crew closed in on the Spartan satellite, the one they had released on Sunday. Then astronaut Ellen Ochoa used the Discovery's robot arm and nabbed the $6 million spacecraft on the very first swipe. The Spartan, that spent 2 days collecting information about solar winds and the sun's corona, that's not a cigar, is now tucked safely inside the shuttle's cargo bay. The Discovery is scheduled to return to Earth with all of this on Friday.
Die gesammelten Daten sollen Aufschluss darüber geben, wie Sonnenwinde entstehen und ob die Sonne für Veränderungen in der Erdatmosphäre mitverantwortlich ist. Die Discovery verfolgte den Satelliten Spartan mit einer Geschwindigkeit von 28.000 Kilometern pro Stunde durchs All. Als er nur noch etwa 10 Meter entfernt war, buxierte ein Roboterarm den künstlichen Himmelskörper in die Ladebucht. Seine Daten werden auf der Erde ausgewertet. Die Astronauten setzen ihre Messungen über die Ozonschicht fort. Am Freitag werden sie in Cape Canaveral zurückerwartet.
Discovery haben den Forschungssatelliten Spartan wieder an Bord genommen. Sie benutzten dazu einen Greifarm. Der 6 Millionen Dollar teure Satellit war am Sonntag ausgesetzt worden. Mit seiner Hilfe wurde untersucht, wie die Sonnenwinde entstehen und ob die Sonne für Veränderungen der Erdatmosphäre mitverantwortlich ist. Von der Discovery-Mission erhoffen sich die Wissenschaftler Informationen über die Zerstörung der Ozonschicht.
Will land is scheduled on Friday, but it may stay up till Saturday if the weather at the Florida landing strip gets bad.
Discovery planmäßig um 13:37 Uhr mitteleuropäischer Sommerzeit auf dem US-Weltraumbahnhof Cape Canaveral in Florida gelandet. Die ursprünglich für Freitag vorgesehene Rückkehr der 5 Astronauten war wegen schlechten Wetters um 24 Stunden verschoben worden. Es war der 54. Space Shuttle-Flug in der Geschichte der US-Raumfahrt. Die Besatzung der Discovery hatte die Erdatmosphäre und die Ozonschicht erkundet. Der Start der Raumfähre Columbia ist weiterhin für den 24. April vorgesehen. Wegen eines Defekts war ihr Start am 22. März 3 Sekunden vor dem Abheben abgebrochen worden.
Cape Canaveral landete Discovery nach 9 Tagen im All wieder auf der Erde. Eine Astronautin und 4 Astronauten hatten einen Satelliten etwa 48 Stunden frei fliegen lassen. Damit wurde die Sonneneinstrahlung gemessen. Mit Radarstrahlen wurde die Ozonschicht untersucht. Nach 16 Flügen ist Discovery die am häufigsten eingesetzte US-Raumfähre. Die Bodenkontrolle nannte die Flugausbeute wertvoll.
Nach 9-tägigem Flug ist die US-Raumfähre Discovery sicher auf der Landebahn des Kennedy-Raumfahrtzentrums in Cape Canaveral gelandet. Wegen schlechten Wetters war die Rückkehr des Space Shuttles um einen Tag verschoben worden. Im Rahmen des NASA-Programms Planet Erde hatten die 5 Astronauten mehrere Experimente zur Erforschung der Ozonschicht und der Sonnenenergie durchgeführt. Die Ergebnisse sollen mit denen einer früheren Mission verglichen werden. Dadurch will man klären, welche Faktoren den lebenswichtigen Schutzschild der Erde zerstören.
On Earth, it touched down this morning at Florida's Kennedy Space Center 1 day late. Yesterday's landing was canceled because of bad weather. The 5-member crew spent 9 days in orbit, conducting tests on the sun and the ozone layer. NASA says Discovery appears in good shape.
Aus dem Kontrollzentrum der NASA wurden die Astronauten der amerikanischen Raumfähre Discovery heute bei ihrer Rückkehr zur Erde begrüßt. Die Landung in Cape Canaveral war wegen schlechten Wetters um einen Tag verschoben worden. Die 5 Astronauten hatten 9 Tage lang die Erde umkreist. Ihre Hauptaufgabe war, zu untersuchen, wie gefährdet die schützende Ozonschicht der Erde ist. Am Forschungsprojekt ATLAS-2 sind auch Wissenschaftler aus Deutschland, Frankreich, den Niederlanden, Belgien und der Schweiz beteiligt.
Nach 9 Tagen im All Ankunft auf dem Weltraumbahnhof Cape Canaveral. Mit 24 Stunden Verspätung landete die amerikanische Raumfähre Discovery wieder auf der Erde. Eine Astronautin und 4 Astronauten hatten Erdatmosphäre und Ozonschicht untersucht. Kein anderes Space Shuttle hat so viele Ausflüge in den Weltraum hinter sich. 16 Mal war Discovery bereits im All. Die Bodenkontrolle nannte die Mission ATLAS-2 erfolgreich.
Fähre Discovery heute sicher zur Erde zurückgekehrt. Wegen schlechten Wetters war die Landung in Cape Canaveral um 24 Stunden verschoben worden. Die 5 Astronauten waren auf dem Flug hauptsächlich mit Messungen der Ozonschicht und der Sonnenenergie befasst.
This is Shuttle Launch Control at T-minus 3 hours and holding. We are counting down toward today's launch of the STS-56 mission, and all is proceeding on schedule here in Firing Room 3 and also at Launch Pad 39B. Liftoff of Discovery's 16th trip into space is planned for the opening of today's launch window at 1:29 a.m. Eastern Time. The window for today's launch extends for almost 2.5 hours. Weather conditions continue to look favorable for an on-time launch at 1:29 a.m. And we have the flight crew for STS-56 getting into their launch and entry suits. Commander Ken Cameron is being assisted getting into his boots. The crew is making the second attempt today. They reported earlier after the weather briefing that they were ready to go. Mission Specialist Mike Foale. He's flying for the second time today. He flew on the first ATLAS mission, and of course today is the second flight of the ATLAS payload. Pilot Stephen Oswald. He's flying in the shuttle for the second time today, and will be involved in helping the orbiter make the over 140 maneuvers required for this particular mission. Crew is getting the last-minute items stowed into their suits that they'll be using. This is Mission Specialist Ellen Ochoa. She'll be using the robot arm to deploy the Spartan satellite, Spartan spacecraft, and will retrieve the Spartan and put it back in the orbiter's payload bay, and it will come back to Earth. This will be Dr. Ochoa's first flight aboard the space shuttle. And we have Mission Specialist Ken Cockrell. He's also flying aboard the shuttle for the first time today. This is Shuttle Launch Control. We have the STS-56 flight crew members leaving the crew quarters at the Operations and Checkout building. Pilot Stephen Oswald, Commander Ken Cameron, Michael Foale, Ellen Ochoa, and Ken Cockrell. The primary payload for this STS-56 mission is ATLAS-2. It is the second in NASA's series of atmospheric laboratory for applications and science space lab missions. We will be showing you live coverage of the astronauts as they enter into the White Room and as they are assisted in getting into the rest of their gear for the flight today. T-minus 2 hours, 37 minutes and counting. This is Shuttle Launch Control. This is a close-up shot of the hydrogen flare stack located at the pad perimeter, inside the pad perimeter. Hydrogen vapor that is vented off from the external tank as the loading operation continues and the topping off phase continues. That propellant is vented off at through that flare stack and away from the vehicle. The flight crew will close and lock their helmet visors in the next few seconds.
ATC TLT, fasten warning memories clear, no unexpected faults.
Copy. Flight crew, close and lock your visors and initiate O2 flow.
Flight crew rod.
15.
T-minus 10, 9, 8. We have a go for engine start. 6, 5, 4, 3, 2, 1. We have ignition. We have liftoff of Discovery on the second mission to Planet Earth research flight.
Houston now controlling. Discovery is underway and it's rolled on course for 57-degree orbit. Three engines on board Discovery now throttling back to 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic. Discovery now traveling 1,000 miles an hour, 3 miles east of the launch pad, altitude 6 miles. Good solid rocket booster separation is confirmed. This is Mission Control, Houston. Discovery is currently passing above the northeast coast of Australia, just along the coast that holds the Great Barrier Reef. Now moving into view is the Spartan-201 platform. On that platform that will be deployed using the mechanical arm on the 4th day of the flight are mounted instruments for the solar wind generation experiment, which will explore the velocity and strength of the solar wind as it flies free from Discovery for a little more than 2 days.
Okay, payload retention logic powers. Those two on. Okay, about to go free drift here, guys.
Discovery Houston, when you get to the next stage, we have no updates to the deploy pad.
Thanks. Nobody. Thank you, Jay. 57 and 28.
Okay, we're doing great. We're just about on time.
What does it say?
Or we're ahead of time, really.
Point. It's at the end of the
this guy.
We've got event timers. We're in attitude.
Standby. Mark.
Okay,
Lost ridge.
Got D-ridge.
Have D-ridge.
Open. Back out slowly.
I see you separating.
There we go. You just back through the pan.
Real nice. Real nice. Clear.
Spartan release.
Okay.
All right. Let's go now. Another couple of feet.
Houston, we have Spartan release.
Wow, look at that picture. I don't know what land they're going on with it.
It's awesome, isn't it? I just...
Spain?
No.
What is it? Doesn't matter.
It's France. We might go on France.
It's 143.
Okay, we're looking for 203 for the start of the maneuver, right?
10 seconds.
Is it pirouetted?
Not yet.
Okay, it's supposed to start in 2 seconds. I don't see anything. It's not pirouetting. There it goes.
Yes, it is.
Okay, it started. Oh, let me call it.
Yeah, go.
This is Discovery. Spartan started its pirouette.
Now receiving live television from Discovery. This showing the Spartan platform 45 feet away. Discovery just moving into nighttime. As it heads out across the Pacific Ocean on a northern track that will take it across the coast of the northwest United States. This view from a camera mounted at the end of Discovery's mechanical arm as it approaches the Spartan platform and the grapple fixture on the arm. In view is the fixture on which the arm will be placed and locked on to retrieve Spartan. Commander Ken Cameron studying Discovery as Ochoa prepares to grasp Spartan with the mechanical arm. Cameron's now switched off Discovery's automatic steering jets. Put the spacecraft into a mode known as free drift so that no steering jets will disturb the arm as it grasps Spartan. And Ochoa now moving the arm in toward the satellite.
Houston, we show a good grapple.
That is a very pretty picture we're still looking at down here.
Houston Discovery, we've captured Spartan.
Great work, Ellen.
What I wanted to talk to you about today was one of the ATLAS instruments called SOLCON, which stands for Solar Constant. But before I describe that, I'd like to talk a little bit about how it fits into the whole ATLAS payload. And I must say it's a little bit hard to keep my concentration because I'm looking out the aft windows at some great views of South America right now. But we'll continue to look. We're in an attitude right right now where the payload bay is facing the sun, and that's because several of the instruments on ATLAS are specifically measuring the sun. And the reason for that is that ATLAS, as you know, is studying the Earth's atmosphere, and what we're trying to find out is what chemicals are present and in what altitudes, and what affects the concentrations of those chemicals, like ozone and other molecules. And we want to be able to distinguish between human activities that might affect our atmosphere and natural effects that affect our atmosphere. And of course, the sun is the primary source of energy for the Earth and its atmosphere, and that's why it's important to be measuring the sun in order to understand our atmosphere. So for the last few hours, we have been in a position where several of the instruments on ATLAS are looking at the sun, and one of these is SOLCON. And what SOLCON is measuring is really the total energy or the total amount of radiation that's coming from the sun. And the reason it was called a solar constant is for many years people thought that that value never changed. It was always the same. But recently they've realized that it does change, and it changes about in an 11-year solar cycle where it goes from a maximum to a min and back to a maximum. And the total amount changes maybe by about 0.1%, which doesn't sound like much, but even small changes in the amount of energy reaching our atmosphere has the potential to have much bigger changes on Earth in the climate or on human health or on other life forms in health. So that's the reason that's important to get precise measurements of this radiation. And it's also important to measure this quantity above the atmosphere because the Earth's atmosphere absorbs radiation from the sun, and it absorbs more in some parts of the solar spectrum than in other parts. So in order to get a very accurate value, we must be above the atmosphere, and that's why the shuttle is a very good tool for using this instrument. SOLCON is an instrument that is sponsored by Belgium and is one of several of the ATLAS instruments that is sponsored or co-sponsored by scientists in the European community. So ATLAS really is an international payload. There are American, Swiss, German, and Belgian scientists all involved in studying the atmosphere. Just to tell you a little bit about how SOLCON works, it basically has two cavities, and during its measurement-taking periods, one of the cavities is open to the sun, and it's black, and therefore it absorbs the energy from the sun and heats up. The other cavity is electrically heated. It's not open to the sun, and it tries to maintain the same temperature or heat flux as the cavity that's open to the sun. And by measuring how much heating is required to maintain that, they're able to obtain a very good value for the amount of energy coming from the sun. One of the important aspects of this instrument, as well as the other ATLAS instruments, is that they're calibrated very carefully before we fly and after we fly, and also as we fly. We're not always in a mode where it's taking measurements. In some of the other orbits that we're in, there are actual calibration equipment inside the instrument that are checking to make sure that the instrument does not degrade while we're up, or if it does, they can at least characterize how it might be changing. This is the second flight of ATLAS, so we have some data of the solar constant from last year. We'll get some this year, and then in subsequent ATLAS flights, we'll be able to get more measurements, and that way we'll be able to plot out the change in the solar constant over the solar cycle. Once we have a better idea of what that value is, we'll be able to say more about whether the sun is making some of the changes that we see in the atmosphere or whether it's due to human activities, and that will give us a chance to understand how to change that. I'm not sure you'll be able to see this, but I've put a diffraction grating up in the window because the sun streaming in through the overhead windows is so bright, and you might be able to get a little bit of the spectrum as I put it here I don't know if that's washing out on your cameras or not, but it's very, very bright here. Very bright purples and blues and green and yellow and red. It's really a pretty sight here to be in this attitude with the sun streaming in through the windows as we orbit the Earth. One of the other instruments on board, which we'll be talking about later, is very similar to SOLCON. It's also measuring the solar constant, so we'll have actually two independent measurements of that on this flight, and that will help the scientists have a lot of confidence in the data and also be able to compare it to similar instruments on longer-term satellites. And I think that's about all we have on SOLCON for you today, and we can get back to you later on some of the instruments later in the flight.
Well, good morning. My name's Michael Foll. I'm a mission specialist on the Space Shuttle Discovery, and we're flying a mission called ATLAS-2. What I want to tell you about today is a particular experiment on ATLAS-2 called MARS, or its acronym stands for the Millimeter Atmospheric Sounder, Millimeter Wave Atmospheric Sounder. We'll show you out in the bay later on what that instrument looks like. It's basically a radar that can receive only radio waves that come from a particular molecule that occurs in very, very small quantities in the Earth's atmosphere. It's called chlorine monoxide. And I have a little story to tell you about how chlorine monoxide could be damaging the ozone that protects us from ultraviolet rays. We launched from Florida north, and we flew up towards the North Pole. You can see it basically as we come up the United States. We come up over the North Pole, or 57 degrees north to be exact, then sweep on down. We rise up towards the North Pole. We catch sunrises and sunsets, which other instruments on Atlas are looking at. However, Mars is actually looking out across the horizon towards the wind that revolves around the North Pole. And I want to tell you a story about chlorofluorocarbons. I'm sure you may have heard of these on the news. And also you know that they're part of the refrigerant that's used in your car, in the air conditioning unit. Here is a chlorofluorocarbon molecule. See it floating here in space. The green things are actually fluorine, and the yellow is chlorine, held together with a carbon atom right at the middle. And what happens is that sunlight, which is actually illuminating my face quite brightly at the moment, comes in and breaks this molecule apart high up in the atmosphere here. A chlorine radical, or just a single chlorine atom, and then the debris of the chlorofluorocarbon just kind of floats away, just as you see it there. But anyway, then we have this chlorine atom floating around in the free space above the Earth's atmosphere, mostly actually in the stratosphere. And it meets the precious ozone molecule that's made up of these red atoms. These are red oxygen atoms. It takes 3 of them, and it makes an ozone molecule. Anyway, here comes a chlorine radical, and it captures the ozone. You see it's joined up there briefly, only very, very briefly, with the ozone. And then immediately after that, it breaks apart. Leaving you with an oxygen molecule and a chlorine monoxide molecule. Chlorine monoxide is the red and yellow molecule here that is being heated by Mars. And you can see the oxygen molecule is just disappearing by my head. Anyway, the story hasn't finished. Along comes another oxygen atom, which happens to be floating around in space here, together with the oxygen molecules and the ozone molecules. And the chlorine monoxide attacks it. As you can see, chemistry in space is slightly tricky. But here we finally got chlorine monoxide, the oxygen atom, and turned it into oxygen, leaving a free chlorine radical floating around again. And all this trouble was caused by the chlorofluorocarbon in the beginning. We've still got the chlorine hanging around, we broke up ozone, and we made some oxygen molecules. So to summarize, basically Mars is an instrument that's particularly looking at chlorine monoxide, the joined up red and yellow molecule. And that molecule is an indicator of how much chlorine has come from the chlorofluorocarbons that have been put into the atmosphere by our refrigerants and other sources. So it's important that ATLAS-2 do this survey for about 8 days, 7 days, monitoring how much chlorine monoxide has developed in the northern latitudes. And that way we will know how much of an ozone hole could be caused by this particular molecule. That's all for the Mars explanation.
Using temperature data, MOS can help determine the rates of chemical production and ozone loss in the upper atmosphere. The investigation uses an antenna, which can be seen now, which scans Earth's atmosphere to collect spectral information at different altitudes. Millimeter wave radiation coming through the atmosphere enters the steerable antenna, which is moving even as we speak, which consists of a 3-foot diameter main reflector and a smaller sub-reflector, and the radiation is then focused into the MOS receiving electronics. Both temperature and ozone concentration will be measured this way, and both are important for a number of reasons.
Right now, we're in an orbit where we have the payload bay facing towards the sun. That's because several of the ATLAS instruments are measuring energy coming from the sun. That way we'll be able to have a better idea over the series of ATLAS missions of how much of an effect the sun has on our atmosphere as opposed to human activities in changing our atmosphere. One of the instruments that is in the bay looking at the sun is called SOLSPEC, which stands for Measurement of the Solar Spectrum. It's a French instrument, one of several of the ATLAS instruments that are sponsored or co-sponsored by international scientists. What this instrument does is separate the sunlight into the different wavelengths and then measure the amount of energy in each of these different wavelengths. Normally we think of just the visible light coming from the sun, and we can use a piece of a prism or a diffraction grating like I have here to separate that light. In fact, if I just put it up here in this overhead window, we'll be able to use it to look at the different colors coming in from the sun. You can see them in this spectrum right here. Well, the SOLSPEC instrument has something very similar to that diffraction grating, only more sophisticated, and it's also looking not only in the visible, but in the ultraviolet and infrared as well, and measuring the amount of radiation in all the different wavelengths. It also calibrates itself every day on orbit, which is very important for these ATLAS instruments because the ultraviolet light coming from the sun degrades the optics, and in order to get the most precise and accurate data, we need to constantly be checking and making sure that we're making the most accurate data possible. So in addition to checking the instrument before and after flight, it's doing it during the flight as well. There's another SOLSPEC instrument that's up on a satellite called Eureka, which was deployed from the Shuttle on a shuttle flight last year, and it's going to be picked up on STS-57 next month. And that will also provide an independent set of data which can be compared to the data that SOLSPEC on ATLAS is getting.
One of the questions that I'm always asked is, what can you see from orbit? A lot of people have the mistaken impression that when we're up in space that you see the world as a blue marble like they saw from Apollo. And I try to explain to them how close you are when you're only 160 miles above the Earth. So why don't you just describe some of the things you can see in the way of cities and city lights, lightning storms, any of that stuff?
Well, you really are a lot higher in terms of perspective, as you know, than in an airplane. And so we can actually see about 2,000 miles from this point out towards the circumference of the Earth all around us. And the Earth is a large but definitely discernible ball above us at the moment. When I say above, of course, that's relative to me. In that sort of 2,000-mile radius, we can see at night thunderstorms flashing. And in fact, one of the most interesting things about the thunderstorms is that they seem to go off simultaneously many, many, many hundreds of miles apart, which in fact is quite incredible, since they must be triggered by the speed of light, by radio waves rather than by sounds, so it wouldn't travel that distance in such a time. The other things we see are cities at night. Taco, on my shift here, has been using an image intensifier in conjunction with a camera called Hercules that allows him to take pictures of cities at night and during the day, and then send those pictures to the ground so that people on the ground can get very high resolution, high definition pictures immediately of what we've just seen.
Let's see. When do we next pass over land? Not for a long, long time.
Coming into view now from the camera located at the middle joint of the mechanical arm is the continent of Australia. As Discovery moves 160 nautical miles above it. This is Mission Control Houston. This view from the Shuttle Discovery showing Houston as it passes overhead on a very clear night, looking down at the Texas Gulf Coast and just having passed over Houston. Now as it moves on up the Gulf Coast,
this is Mission Control Houston. Discovery is currently making a swing from the northwest to the southeast across the continental United States. The orbiter's currently moving about 80 miles or so west-northwest of Cedar Falls, Iowa, making a pass down from there through the southeastern portions of the United States, heading out across the Atlantic Ocean, crossing the coastline somewhere around the coast of Georgia and Florida. In the cruise timeline, Commander Ken Cameron is scheduled to be conducting a ham radio call very shortly with the Tishomingo County High School. That's in Luca, Mississippi. And that is coming up very shortly as the orbiter moves within range of that area of the country. Southern tip of Florida now visible from Discovery as the orbiter's moving just a little to the west-northwest of Cape Coral, Florida. The Keys down near the southern tip of Florida, clearly visible from Discovery. The city of Miami on the southern tip of Florida. This is the 101st orbit of the mission of Discovery.
This view looking back from Discovery as it continues out across Upper Canada now. Discovery will continue across Hudson Bay and then off the coast of Newfoundland. Discovery now continuing.
Discovery Houston, 1 minute switching over to the East Tidris, and we're seeing a beautiful view of what we think's the aurora out there. How's it look out the window?
Jay, we're missing it. We're all downstairs in the mid-deck reconfiguring things and getting the last jobs done before the redshift goes to sleep. We'll have to take your word for it.
Roger that. We'll see you on the other side.
Discovery above Canada as it television cameras pick up the northern lights. Television is from Discovery as it heads out across the Mediterranean Sea.
Inco Flight, where are we on everything? We got the SPCs up and we got the MABs running, everything's going.
Everything's complete.
Thank you, sir.
T0, SRB ignition.
Liftoff confirmed.
Thank you.
Roll program, Houston.
Roger, roll, Discovery.
Throttle up, 3 at 104.
What throttle up?
Discovery, go at throttle up.
Roger, go at throttle up.
SRB SEP.
Thank you.
103 converged.
Stand by for 2-engine tail. Mark.
Discovery, 2-engine tail.
Roger. Single engine Zaragoza 104.
Discovery, single engine Zaragoza 104.
Roger.
Like you said, we got a line problem with meter. We're checking.
Copy that. Is that why we hard the echo?
Discovery Houston, we show a nominal MECO, no ohms 1 required, and you have a go for the photo DTO.
Roger, we concur.
Flight payloads, we got all good, ready for launch indications also.
Okay, good. You see no reasons why we shouldn't be unberthing.
Flight payload sees none.
PDRS is still go.
Okay.
We're just a few inches away, flight.
Copy.
And we are at low hover. Brakes are on.
All operators, a reminder, in 2 minutes I'll come around the room for a go for release. All operators, I'll be going around the room for go for deploy. Prop.
Go.
GNC. Go. FIDO.
Go.
Rendezvous.
Go.
DPS.
Go.
Payloads.
Go.
Okay, Eagle and ECOM, our systems are all looking there. Good there? Go. We're go. Okay. INCO. We're go. PDRS.
Go.
Okay, FAO, we have any loose cleanup items?
No, sir, I'm just watching for steps in part 2 of this procedure.
Okay. Capcom, they got to go for deploy.
Discovery Houston, your go for Spartan deploy.
Roger, go for deploy. Thank you.
Discovery, 2 minutes to hand it over to the East Tetris.
Spartan is
Houston, we have
released.
Spartan release.
We copy.
GNC, attitude check.
1.4 degrees out at release.
Wi-Fi looks like he's got a good burn.
Copy that. Burn report prop. And Rendezvous FIDO, you happy with his burn?
Flight Rendezvous, yes, sir.
And Flight Fighter, I'm real happy.
Okay, we're on the way in.
Yes, sir.
Discovery Houston, we saw a good TI burn. We're about a minute from losing you through Diego, and we'll pick you up on the west satellite at 2355.
Roger that, and we'll take the T1 TIG as it comes up on the spec.
And we've been real happy with your laser data, showing about a 20-foot delta between that and the radar.
Roger, and some of that may be time delay on the call.
We concur.
Nice work, Inco. And PDRS flight, arm status is go.
Arm status is go. We're standing by.
PDRS flight, is that, that's not arm motion either, is it? That's,
No, sir. That's all piloting right there.
okay.
I'll report as soon as I see arm motion.
Should be ready to go momentarily.
Capture in progress flight. That is a very pretty picture we're still looking at down here.
And PDRS flight,
Good grapple flight.
or grappled and rigidized.
Yes, sir. Secured.
Captured Spartan.
Great work, Alan.
Flight rendezvous.
Go rendezvous.
We're there. My compliments to the crew.
Yes, sir. That goes for all of us there, Capcom. Good job.
And Discovery Houston, there's a lot of smiles in the room down here. Congratulations on a fantastic rendezvous and grapple of the Spartan.
Okay, we show 5 of 6. We have 3 on the B side, so we do have good ready for latch indication.
Nice work.
And there's the
There's
one.
all 6.
We think we're there, Houston.
Concur.
We concur. Nice work. That was a real good thought, changing the reference frame. That worked slick.
She's smart lady.
That's the truth. It sounds like you're all working as a great crew together. It sounds great from down here.
Okay, but he feels the hack turn is not, if we get the information to Ken, then that will solve the aggressiveness on the hack, and getting on the hack and stay on it should be okay.
Okay. Well, it sounds like we've been able to find some energy reserve where we're losing it on the bottom, so Capcom, we got to go from the room here, and based on what we're getting from the STA pilots' reports, I think I'm go for the deorbit burn, so why don't we go ahead and give that to Ken and let him get on into the procedures.
Go ahead.
You have a go for Ops 302, and you have a go for the deorbit burn. And I've got some words on flying the hack and final approach whenever you're ready.
Flight Fido.
Go, Fido.
Based on the good burn, I'd like to release Edwards support and SMS support as well.
Yes, sir.
Discovery Houston, we saw a good deorbit burn.
Roger, look at that.
Capcom flight.
Go. Your go for nominal drag chute deploy. A reminder to select manual speed brake, full closed at 3,000 feet, and full open after main gear touchdown.
Roger, the drag chute and the speed brake.
And Discovery, your predicted normalized touchdown is 1,600 feet down the runway.
Processing MLS.
Gear stand and lock. Brake isoles open.
Okay.
Speed brake coming up in flight.
Go through touchdown.
Ground speed enable, auto load relief.
Sorry, DPS.
Wheel stop, Houston.
Copy, wheel stop Discovery, and you got a bunch of smiling faces in the room here. That was a beautiful piece of flying, Ken. And welcome home to the crew after a super mission.
Thanks very much. Thanks very much to the whole NASA team for making this possible. It was a privilege to be part of it.
Okay, if you'll stand by, we'll go around the room and check for any post-landing deltas.
Okay, all flight controllers, LRD has taken over, and they now have control of the vehicle. GC, they want you to hang in until the command handover is complete, but they've given the go for release of the flight team.
Discovery Houston.
Go ahead, Houston.
Andy, we're going to be signing off. If you've got good comm with OTC.
Okay, I copy that, and we'll be turning it over to the SCOs here also. Thanks.
Okay, we'll see you back home.
This is Kennedy Space Center Shuttle Control, watching a sunrise here at Kennedy Space Center, where things are very busy, getting ready for today's landing of Discovery, ending the STS-56 flight.
Discovery Houston, on energy approaching the hack. No change to weather. Winds are 310 at 5, peak 8. Your go for nominal drag chute deploy. A reminder to select manual speed brake, full closed at 3,000 feet, and full open after main gear touchdown.
Roger the drag chute and the speed brake.
Discovery is approaching waypoint 1 at the point at which it begins the heading alignment turn.
Discovery on energy at the 180.
Energy is looking good as Cameron brings Discovery home around the heading alignment turn.
Discovery on energy at the 90.
So far, Cameron's right on the money. Everything's looking good. Range to the runway 8 miles, altitude 15,000 feet, descending at a rate of 200 feet per second. Discovery is now processing microwave landing system data, refining its sense of its course to the runway.
Discovery on and on. Final wind check 310 at 5, peak 8.
Roger.
Discovery's on glide slope and on center line, reaching for runway 33. A range of 5 miles, altitude 8,600 feet, descending at about 140 feet per second. Discovery's beginning to flare a little bit, taking some of the steep angle out of the angle of approach. Beginning to induce drag and slow the vehicle as it approaches the runway. Range 3 miles, altitude 4,800 feet.
We're seeing final flare. Should see the landing gear coming down shortly. Main gear is down and locked. Main gear touchdown. Standing by for drag chute deployment. Chutes deployed and the nose gear is down. Discovery's crew returns with a bounty of new knowledge of the sun, our home planet, and its fragile atmosphere. Discovery rolling out on runway 33.